Hello everyone, this is chapter 4 part 3. In this part we'll continue with the regression analysis. So fitting a regression line is the topic of this part. So population regression line, or this is the true relationship between some variables, right? Population regression line is the equation or line representing a true or actual underlying relationship between the dependent variable and explanatory variables. It can be more than one variable, but in our case you have your dependent variable, independent explanatory variable. Okay, this is that true relationship, that holy object we talked about. Alright, so we also have sample regression line. This is going to be the estimated model. It's an estimate of the true population regression line and represents a line that best fits the scattered data points in the sample. So we're going to have hat, y hat, a hat parameter estimate, b hat times x. Okay, where a hat and b hat are the fitted or predicted values. We also call them coefficient estimates. Of the true population parameters a and b, and y hat is the fitted or predicted value of y. Okay, the predicted value of y is obtained by substituting the value of x into the sample regression equation. For instance, let's take a look at this data set. This is the sales and advertising expenditures of sample of 7 travel agencies. Travel agency A spent $2,000 and the sales ended up being $15,000, so on and so forth. And we have this travel agency, for instance, G, spent $7,000. The real value of the sales is $60,000. So these are all scattered data points on the sales and advertising x and y axis plane, right? These are all scattered data points, so they really don't connect with a straight line. But what we're trying to do, we're trying to SI hat equals a hat plus b hat AI. We're trying to find this relationship, the line that fits the best, not necessarily passing through all points. So when you estimate this line, this is the kind of line you get. Look, different data points, spending, advertising spending, and your sales. So this is, for instance, travel agency G's data point, right? They spent $7,000 in advertising. In reality, their sales were $60,000. But when you have the sample regression line that you estimate, fitted regression line by estimating a ordinary least squares regression model, you are, let's say, getting this sample regression line. Okay, so in this sample regression line, this gives you some predictive results, right? It's based on this estimate plus 4.9719 times advertising was $7,000. So this model, that zero is too many zeros, 307,000, what you spent in place of A, you are supposed to, the model gives you $46,376 of sales predicted. However, in reality, it is 60,000. That is fine. This is what we call the residual, that little error the model makes, which is fine. So it's the true value minus predicted value of sales. Okay, so if you look at the general residual formula, it's a true value of y, right? There's no hats there. True value of y minus the predicted value of y I hat. Okay, so that's your residual. So what we do in regression is we look at these little distances. We sum of square residuals. We sum these, we square them. These distances take the square EI hat. Okay, so it's always positive, not sometimes negative. That's important. Sum them up from I1 to N, whatever the number of observation is. So we minimize this to find this line. We are not going to go into detail of that. So let's talk about the method that we use to find these A hat and B hat parameter estimates, we use a method of least squares. This is a method of estimating parameters of a linear regression equation by finding the line that minimizes the sum of the square distances from each sample data point to sample regression line. Basically what we do is that, folks, residual, right? So this is yi minus yi hat. We sum these up, square, right, from I1 to N. This is N is the sample size. In this case we have A to G, right? All these companies from Y to N. This is general formula. We minimize these distances. We don't need to know the technical details, but I want you to understand how we find it. Parameter estimates. So estimator, I like saying it. Estimators are the formulas by which the estimates of parameters are computed. Okay, so there's a formula for A hat and B hat. All right, parameter estimates are obtained from substituting sample data into estimators to find these are going to be numbers. So there are formulas and parameter estimates will be numbers, just like in this example, A hat, B hat, these are specific numbers, but there are formulas associated with that is beyond our scope. Residual, we talked about this before, is the difference between the actual and fitted values of yi. Okay, process is equivalent to fitting a line through a scatter diagram of the sample data points. But look, we have talked about this. I always talk about stuff we're going through beforehand. So let's say I have data, right? The relationship is this. So I'm trying to find the best line. For instance, in this case, it's a downward sloping line. Yi hat equals A hat plus B hat xi. So I'm trying to find a line that has minimizing these residuals. These are distances. This is residual 1, 2, 3. I'm just marking the distances. So I take the square of these distances, right, sum them up and find a minimum, just to estimate A hat and B hat. Okay, so parameter estimates, we talked about this and this. All right, so this is a general example of regression result. So this is what we get when this is a general printout. Okay, so this is what you see. It says dependent variable S. So I'm estimating this model, A plus B AI. So you will see observations. This is number of observations from A to G, 7 observations. You will see something, R squared, we'll talk about that, F ratio, P value on F. These are all very important. We'll talk about those in this chapter. So variable, you have intercept. So basically this guy, A hat parameter estimate, is right here. Variable A, this is the coefficient of variable A, so it's going to be slope beta hat. Okay, so these are the parameter estimates. So you can write down this equation SI hat instead of A hat, right? A hat plus B hat AI. So you can write it down as SI hat equals A hat 11,573 plus, what is this? Is it a, it's 4.97191 AI. Okay, so this is your estimated predicted model. These are a little bit tight, I'm sorry. Okay, so this is an example Excel printout, right? It's the same thing. This is like a cleaned up version, but this is what you'll see in Excel when you run a regression. It will give you adjusted R squared or R squared. We'll talk about R squared observations. You're going to see F value, significance of F. You're going to have coefficient estimates. This is A hat, B hat. Standard errors, very important, t-stats, p-values, and the confidence intervals. So next, folks, I am going to actually go to Excel and we're going to run our very first regression model. So this is based off of this marketing agencies, these travel agencies and their advertising and sales. So this is the same data set. I'm gonna make this a little bigger. We learned how to download the tool pack, right? Data analysis tool pack is right here. So this is companies A through G. Sales are on column B. In dollars, advertising expenditure is on column 3. So how do we run our regression? After you learn how to download your analysis pack. So if you go right your home, go to data tab. If you don't see data analysis, this pack, okay, this is an add-in, right? I just uploaded a video and you can watch that, how to download this tool pack. So once you do that, you're going to click on data analysis and there are options, right? I'm going to pick regression. Okay. So input Y range. This is your Y variable. Just click on here. So data analysis regression, right? We're going to change this. We're going to do this. And we have labels too. Okay. And there you go. If you do this, it will grab properly labeled. So 7 observations, right? We find the same result, intercept, and you have the coefficient estimate of advertising. This is A hat and B hat, right? And the dependent variable is your sales. So same coefficient estimates, we're going to learn all about that. It is very, very easy to get this result. If you do not label, if you don't hit the label, it's going to give you just X variable. And if you know your X variable, which we do, it's the sales. Advertising. Therefore, it will show you advertising expenditure. And let's go back to our results. So what we did is we estimated this line by running that simple regression. Okay, so this is it. It's not that hard. Now next we are going to see some interesting stuff in part 4. I'll see you in part 4.